draft physics video, draft science. Anyway, I think I'll just do comments on some stuff and talk about some stuff related to the first law video, laws. Just to make some clarifications, to emphasize, the facts. The idea that this gravity thing isn't something the thing's producing. Matter doesn't produce gravity. It causes it to be initiated out of the pressure field by existing, by being an impediment, by being something that blocks the pressure. It creates an imbalance. There's got to be a way of saying this. Well, anyway, it's not generating anything. It's just providing a mechanism to reveal what already exists out there. I was going to say, it's like turning it on, but it's not turning it on. It's just causing. It's like when you throw a pebble into a stream and you get the ripples. It's not, the medium is carrying it. And there's a medium. That's what gravity is. It's a medium. Anyway, so there's a comment on the what the fuck video, this Inuit guy, whatever, nice enough, whatever. But, I wish you'd put the science questions, the physics questions on the Draft Science channel. I mean, just makes sense. Alright, how do you explain gravitational lensing if space does not bend? So I explained that all lensing is caused by light interacting with charged atomic particles that commonly have a higher density very near the surface of all material substances, from slits to galaxies. And then he says, wouldn't that mean that the light is bending? Question mark. I thought light was isotropic. Again, the light doesn't bend. So let's go through this again. Light goes from point A to point B in a straight line, and that's all it does. There's no dimension of time, there's no dimension of space beyond the fact that there's the three dimensions we know of: up, down, left, right, forward, back. That's all there is. There's three dimensions, there's no fourth dimension, no fifth, there's no other thing. There's no other part of physical reality. That's it. There's a location in those dimensions, and then there's a trajectory that you have. And a photon has a constant trajectory and a constant speed. Yeah, I mean, the direction isn't constant. It's constant until something changes it. But something has to change it. It doesn't change it on its own. And gravity can't change it, because it's already traveling through gravity. Gravity is what it lives in. So, again, I'll explain that. I guess the first thing I'll say is that photons, when they're the reason why gravity can't bend light, can't change light, is, again, you got to remember that photons are just a frequency of gravity. So they're the same thing as gravity. They're just things moving. And so let's say something hits this thing and pushes it down. As I explained before, all the interactions are really straight line interactions, right? They only look like something happened. Everything just goes where it was going, and this can be understood as this goes straight to here. This goes straight. But what's really happening is, no, it gets bent by, it changes direction because of the interaction. But even though the outcome is exactly the same, you have two things leaving on these trajectories. Whether you think of them going through each other, or whether you think of them fully interacting, the end result is the same. And that's what happens with photons and gravity. If gravity hits a photon, the photon's energy is still going to go this way. So even if this photon gets pushed down this way, this one will leave that way. You get it? So the two interact, so it's the same diagram as this. Two things come in, two things go out exactly on a straight line trajectory. But the trick is that all that happened here is this is a different graviton. Though this graviton did move to here, but this one, more importantly coming down, went over here. So exactly the same frequency will be maintained on this trajectory. Alright, so even though the real photon got knocked down here, the signal, the frequency, is carried. So gravity couldn't affect. Gravity can't affect gravity. And again, photon is just gravity that has a frequency, and that's why we can detect it. It's because the gravitons come at a frequency. And that's the only thing that distinguishes gravitons from photons. All this light around me right now, these photons, it's a tiny percentage of the gravitons coming in all directions at me. I'm being bombarded by gravitons, 99% more gravitons than photons. But they're exactly the same thing. One has a frequency, one doesn't. Now the key thing in diffraction is that, okay, so the photons always go in this thing. This frequency is always maintained. And what happens when they interact with an electron, let's say, is that they'll either be absorbed or they won't be absorbed. So they'll have an interaction. That means the photon will definitely go into the electron system. And the catch is it'll either become part of the electron and maintain an orbit, or it won't have enough gravity. The electron won't have the capacity to hold the photon, and what will happen is the photon will not make a full orbit and it will leave in a new direction. So it came in this direction, it will leave in this direction because the electron doesn't have the energy to hold it. And in most circumstances, there's rules about reflection, in the sense that angle in, angle out, rules that are relatively consistent. But obviously you can imagine that if the electrons are in certain orientations, because they have like the iron filings around a magnet, they line up in a certain way. And so now if light was to hit those, it would reflect in a certain way, right? Because they're all lined up like little mirrors. Well, the same thing is happening with the electrons around my body or the electrons around the sun. All those particles are charged. All those particles are oriented in a direction, polarized by their relationships, and therefore they'll reflect the light or diffract it in very specific ways that don't obey the normal rule of angle in, angle out. And that's all that's happening with diffraction, is that there's a circumstance where the orientation is specific and consistent among all the electrons, and there's a consistent result in terms of a certain angle of reflection. But it really has to do with the fact that it's not absorbed. So it gets a little tricky, because sometimes it's absorbed and then it's just readmitted in at a different wavelength. So you have to remember it's made of two components. The photon is two gravitons, and so it goes in at a certain frequency, and that frequency is altered because the photon that goes in isn't the photon that leaves. It's made of a different set of gravitons. So you have to understand it like if something were to fly into the solar system, and it's going to change the gravitational balance of the entire system. everything's orbit will be affected. So if something the size of like Neptune or whatever flies into the solar system, it's going to disrupt the orbits of every single other planet, because it's going to change the gravitational balance. And that's what the photon, when it goes, those gravitons go in, and they essentially create a gravitational imbalance that wobbles the entire system, and the system can't hold all the parts, so it keeps these photons and it releases some others because it just doesn't have the gravity anymore to hold them. It's not the best way to say it, but you can understand that if if something goes in here and drags the planets, the orbiting bodies a little bit off, that this now is a bigger system, and that these orbits are now weaker, not stronger, and that there's more likelihood of something flying out if its distance from the core has been increased. So you can sort of understand that if the orbit gets wider and it has any kind of velocity at all, that velocity will tend to release it from the gravity. Alright, is that a good enough explanation? So light isn't bent like in any kind of curve way. It's always it's always a geometric thing that's happening to all the photons, all the graviton. Everything's moving in very geometric ways, square. And it's just, we think of circle because it looks like one in the big picture, but it's really not. If you could take if we had a microscope good enough, we could see that it's not a smooth line, it's a jagged line. And so there's no bending. And the point is the light will go from point A to point B unless something with an orbit has to interfere with it. Something made of subnuclear parts have to affect it. But they can't just be gravitons alone. They have to be something where it's going to get caught in an orbit. That's how its direction gets changed. It's kind of like, look, if I shoot a spaceship at the moon, we know that I can go around the moon a few hundred times and then leave any direction I want. Once I make one orbit, I can essentially, just by adding a little bit of thrust, I can leave at any point in any direction. And that's sort of without losing anything. Okay, the energy I gained by getting pulled in is the same amount of energy I'll have to throw out to get out. So I can completely change my direction without any exchange of energy. Alright, that's probably enough on that subject. Yeah. Alright, so on to Skid Row. See if I want to do his first, or I'll do some other first. Dark matter. So can Draft Science Reader tell me if Gary has any videos dealing with dark matter? I don't deal with it extensively. I think I've just mentioned it as, I think this is another piece of evidence that Einstein's lensing argument is not accurate. It's not gravitational lensing. It's subnuclear part diffraction. Every heavy thing in the universe, everything that's blocking gravity and creating the imbalance, as I'll explain later, is going to have an atmosphere of particles. The atmosphere around the Earth isn't just the oxygen we're breathing. The atmosphere essentially goes much deeper in terms of, if you count all the charged particles, they go way out into space. And the sun especially has a huge atmosphere of charged particles surrounding it. And it's that atmosphere that's diffracting light. And that atmosphere isn't dependent necessarily on just gravity. It's dependent on how old the system is. the older the system is, the less likely there's going to be clutter and dirt. And it depends on how much the body is radiating, burning. So suns burn, which means they spew a lot of crap that ends up going back into the sun. Not everything the sun burps out is just light that just flies out, that has escape velocity. A lot of what the sun produces doesn't have escape velocity, and it ends up just bouncing on this, bouncing off, getting spewed out, pulling back in, spewed out, pulled back in. And it's that heavy atmosphere that's doing the diffracting. So dark matter is just a contrivance that they had to come up with because they couldn't explain why they have a whole bunch of what appears to be gravity, but they don't have sufficient lensing to account for the amount of what appears to be the gravity, so they invent dark matter to create unseen gravity. So anyway, inflation theory, I don't go for this whole space expanding thing or any of that kind of crap, so if that's what you mean by inflation theory, forget it. The channel search didn't return anything. I mean, I go for the idea that the explosion of the universe is still taking place. So in that sense, there's an expansion. But, yeah, I'll just leave it there. I don't think gravity is consistent throughout the entire universe. So anyway, so this guy, good explanation of everything I've been describing. I was just thinking, if the universe was at balance in the beginning of time, what caused the unbalance? Okay, I know these arrows are going anywhere, but I mean after the Big Bang. An explosion usually ejects stuff 360 degrees and that stuff doesn't hit each other. Yeah, that's only a theoretical thing though, right? That's if we have an ideal circumstance where all the things are solid, like a ball of marbles, and I explode the marbles out. They'll just go as individual marbles in 360 degree way. But we could argue that what's happening in the Big Bang is sort of like what happens when a sun supernovas or something. And what really is going to happen is the interior products actually are under they're under pressure, but it's not gravitational pressure. The pressure the inside of the Earth is feeling, the inside of the Earth is feeling no gravity at all. I mean, not at all. The wrong word. It's feeling much less gravity than the stuff on the surface. So we have this perception that the gravity gets stronger as you go inside the Earth, but no, it actually gets weaker and weaker and weaker and weaker. And the stuff in the middle has the weakest gravity. And so what you have to sort of understand is that there's going to be a layering of these gravitational bodies where the matter is going to, based on its density, be moved. So it's like water pressure. Like you go underwater, you feel all this pressure. Well, that pressure isn't gravity. That pressure is the water being accelerated by gravity, which is different. It sounds like it's the same thing, but it's not. So the higher pressure is just from the amount of accelerated matter being accelerated by gravity above you, and the density of that stuff that's above you. How else to say this? So what I'm trying to get to is that the Big Bang, theoretically, could have had crust. Okay, the plasma could have a crust, and it could have a core, and those things could be different. So when it explodes, pieces of the crust tear off, and now they become essentially a mirror. So when the photons come out, they hit the mirror and bounce So that's where you start making all this multi-directionality, is that the explosion is reflecting off of the crust as the explosion takes place. The explosion can't expand so fast enough because the heavier stuff, the slower stuff, is on the outside, and the faster stuff is on the inside. Yeah, that was a simple way to say it. Okay. And as if it doesn't hit each other. So this, theoretically, the Big Bang wouldn't be a perfect plasma, just like the sun isn't a perfect plasma. It's going to be a plasma that's going to have layers, and the layers are going to have different densities. And those different densities are what creates the reflections that create the diverse directionality. That it create the pressure inside, essentially, the restricted exploding vessel. So inside the explosion, the pressure increases. It's like a nuclear bomb, right? The pressure wave can't move as fast as it wants to. It's blocked by all the stuff in its way. And so it builds up pressure. It's kind of like making a pipe bomb. You want to. The whole point is to create things that won't allow the pressure of the explosion to release. So the pressure goes higher and higher and higher, and then when it finally breaks or tears, it tears catastrophically because now the pressure is so high. So that's kind of what we're in. We're in this very high pressure part of the explosion. That's why we have a lot of gravity. Alright, explosion. So how they attract each other after the explosion. Well, again, they don't attract each other. They get pushed into each other by the pressure. So the pressure exists. The matter, the stuff that's matter, is already slowed down. Matter could never move the speed of light, so matter is already a collection of things moving in different directions. That's how you create orbitals, is to collect a bunch of stuff that was moving in different directions to fill the circle. And so it's a collection of, an orbit would be a collection of arrows going in the 360 degrees of that 2 dimensions. So how did they attract each other? Did the Big Bang really happen? Whatever. If the furthest galaxies are going away from each other, what makes sense of the direction of the explosion? But how an explosion made arrows hit each other to form imbalance, I don't know. Well, I guess all I'm saying is I think the explanation is just that the Big Bang doesn't happen with a perfect plasma. It happens with a plasma that does have different density. It's already got some matter in it, apparently. Whether it's just hydrogen versus nuclear protons or some other smaller bits. The point is a proton can't move the speed of light theoretically. It's made, electron can't, because it's made of stuff moving the speed of light in different directions. It can't go in one direction the speed of light because it's made of stuff going different directions. I don't know. Something must have happened just after the explosion to let the quanta change their direction to actually hit each other, or another expansion of Big Bang. Okay, well, I won't keep going, I don't think. It never happened, and the universe is already in chaos, so the galaxies are going away from each other because the universe was already at imbalance. I think the only reason why I would say there was a Big Bang is the fact that there is this stuff at the end of the universe appears to be moving away from us really fast, which in my opinion indicates they're going into a less pressure field, which means the gravity, right? We have a lot of gravity, high pressure. They have less gravity, low pressure. They're going to be pushed towards the low pressure. So that's why they're moving so fast, is because they're leaving gravity. They're leaving a balanced gravity and heading it's the outside the well, I don't know how to say that. Um, they're getting hit by arrows going in one direction more than arrows going in any other direction. Yeah, because they're outside of a high pressure. They're on the, you know, they're on this. They're on, ironically, the surface of the Earth is the highest gravity, and the inverse is true on the going out part. Your highest velocity will be achieved when you hit the outside of the explosion. Yeah, okay. That's about a better way to say it. Alright, Skid Row Radio. Well, let me do this first. So this is just a quote from an article some guy posted. You know, where a Nobel Prize winner was just talking about how the scientific journals are creating a sham system. You even have journals that are paying people for articles, and, you know, the peer review, and that, you know, researchers are making money just submitting bullshit, silly articles because they can make money submitting silly articles, which is, you know, kind of disappointing. But anyway, so yeah, just as a shot at peer review, which, yeah, is turned into shit. So anyway, this guy has created a website, apparently our science journal of his own, where he's going to allow for more liberal submissions about real science. So we'll see what happens there. So anyway, this is just Skid Row Radio. You know, I love Skid Row. But anyway, he's a he just can't let go of this phantasmagorical crap. But anyway, I was thinking about Planck last night in relation to quantum tunneling. There's no such thing as quantum tunneling. Now, if you want to think about the fact that there's two ways to travel in an atom, you know what I mean? You could travel this way and go through here and go circular in here and that kind of stuff, or, you know, you might be able to travel from this side. You know, usually particles have to go around the nucleus to get from here to here. But yeah, maybe it's possible to go the way the gravity is going. You can take the straight route. But you can't go faster than the speed of light. You can only go a shorter distance than some alternative distance. And obviously light has to travel in electrons. You know, it has to obey these gravitational rules. So you might be able to argue that there's a shorter distance to get through an atom. It's like glass. Glass slows light down, right? But light doesn't really slow down. All it's doing when it's going through the glass is it's getting captured and then released and then captured and then released and then captured and released. It's going the long way around the electrons of the material structure. So it's traveling 40% more distance. Now clearly you could call it tunneling if something didn't bother having to do that, if it could just go straight through the glass. But light isn't transmitted. Glass isn't transparent in the sense that people think. It isn't clear that photons can just shoot through and they're not hitting anything. No, they're hitting things that are specifically designed in a sense where they will transmit a photon from one end of the glass to the other, but they're not doing it because the photon is uninterrupted. It's exactly the opposite. It's highly interrupted, and it's being carried by the molecules. The molecules are handing it off to each other, and so that process takes 40% longer. So you might think of it as tunneling. If I was to say, I can get a photon to go from this side of the glass to that side of the glass in a straight line. But it's not really tunneling. It's not faster than the speed of light. It's just taking a shorter route. Light often takes a longer route. That doesn't mean the light is slower. Alright. If space-time, there is no space-time, has a frame rate, well, it's certainly not something Einstein said anything about, and it's granular. Could the movement of things moving at the speed of light be governed by traveling along a directional grid? Well, the point is the grid is already built in to the speed of light. That's the grid. The Planck distance you travel that allows for the creation of a constant speed. So you have a constant distance, there'll always be a constant amount of time it'll take to go in a straight line across that distance. So again, we're just talking about straight lines versus crooked lines, or crooked routes. And so, yes, the granularity isn't even a necessary perception. I mean, you can perceive it either way. It doesn't matter. Once you establish the constant, you've already established the frame rate and the granularity. But it's sort of irrelevant. How was to put that? You don't need to think of it as a clock speed. You could just think of it as a distance limitation or some other kind of thing. But yes, there's a rigid association between time and distance. So as long as the movement is in a straight line, there's a rigid, unbreakable connection, consistent, constant between distance and time. Able to flick through reality like the pages of a book. Yeah, well, that's not, no, there's a straight line. That's all there is. There's nothing faster than a straight line. But you can't go more distance faster than the speed of light in a straight line. That's not possible. But of course, a proton is orders of magnitude bigger than a Planck. Well, yeah, and so is an electron, because they're made out of the quanta, and a lot of the quanta. And so there's a lot of distance being traveled in the maintenance of those orbits, and that distance has nothing to do with the straight line, the movement they're moving. They're moving in very unstraight lines. To go from here to here, the electron is doing this to do it. Okay, to be fair, I was stoned at the time, love thinking about things, what a mindfuck, well, whatever. Don't know if you'll be able to watch this from the other side of the pond, give it a go, it's a decent show. No, it isn't decent, so anyway, this is last week's show, the quantum tunneling episode isn't online yet. Well, they're all bad. This is that, Al, whatever his name is. I have to go look it up, I guess. Pooh. So anyway, yeah, I can't play it. But it's that Jim Al-Kahari guy. So this is the guy who made such a mess. I made a video. You know, we just lied about what the two-slit experiment, what the actual experiment is, what actual experiments have been done. And, you know, I think he's a horrible scientist. And, you know, finding connections between quantum physics and life on Earth is just silly. It's silly. There's no magic here. There's no all these perceptions you have of this, you know, waving magnetism bullshit. All this is all bullshit. A photon is a frickin' thing, okay, and it's just rocks moving at a frequency, and that's all it is. It's just if I took two rocks and I threw them, all right, to have a distance between the rocks, that's light. And if the rocks are indestructible and only do whatever they just move at a constant speed, you can get this. I mean, I can go back to the fish metaphor, but you know. Yeah. So anyway, so where was I? I don't think there was anything else. I don't know who Ken I was. I didn't see his comment. The Earth doesn't return to a point A. That when it goes around the Sun, the entire solar system is not directed true. The Earth ends up in an entirely different place upon its rotation around the Sun. Yes, the entire solar system, like atoms, is wobbling its way through the galaxy. Alright, so the thing I wanted to get to was, now this is something completely conceited, by, you know, all the physicists. Um, you know, Stanford and you know all these guys, the math. But this is just one of those things where you say, oh, that's darn curious. So here we have this huge connection, you know, between electricity and gravity. So there's another connection that, you know, people just aren't aware of. But if I create a ring of matter, in here there's no gravity. Okay, you won't detect any gravity anywhere in here. Nowhere. The thing in here is completely without gravity. None. Right? You could be right next to this surface, yet this surface will produce no gravity. None. And electricity does the same thing. The charge is entirely a surface phenomenon. And you know, you can create this thing called some kind of cage, right? The electric cage or whatever. You know, you can have huge amounts of electricity traveling right around you, but you're in a cage of it. It's on the outside and you're on the inside. So, so this body would be, so this could have a very large mass, right? And it would be, from out here, it would look like a solid object, say this big. Okay, I mean the same mass of a solid object versus this hollow object. And they could have the, you know, the same mass, they would produce exactly the same gravity from something on the outside. But something on the inside, no gravity. And why that is this inverse square thing again. So you have to kind of think about this body as having a cone of what can influence it. So you think about it like there's matter on one side of an arbitrary line, there's mass on this side, and then there's mass on this side. Now there's two masses, look bigger and smaller, but you have to think about it in terms of this cone idea, that this is what comes in, right? And this is closer, so the density of these arrows would be very high, right? You can understand that there'd be a lot of them because they're well, yeah, it's not even that there'd be a lot, right? You can sort of understand that there's going to be the same exact amount that there is over here because it's an arbitrary, you know, the universe has equal pressure, right? So on both sides of this line there's going to be exactly the same pressure in the universe. And so there's no imbalance in pressure because this has every vector and this has every vector. But the key point is the further away this matter is, the weaker, you know, by the r squared rule, inverse square rule. So this is like, you could just think of this has a larger, there's a bigger cone, okay, that of influence, but it's all weaker because it's further away. So all the mass is further away from this than this. So even though there's so this amount of mass is exactly proportional to the inverse square. So this would be 4 times the amount of matter on this side. And that's so there's 4 times the mass over here, and every time you do this you'll just end up creating a different so if you're directly in the middle, yeah, I gotta explain this a little more carefully. Let's go back to the cone thing, because that's the safe bet, right? I think it's safe. I just have to figure out how to draw it. So when you're in different locations, you just say, here's the cone of influence, right? And here's your cone of influence in the other direction. So you can sort of understand that this matter is all further away, so it's going to be weaker, and this is all closer, so it's going to be stronger. So if we whether represent that in lines closer to each other or something else. So even though there's more lines coming in from this side, these are, you know, blocked, say, gravity lines. These are closer, so they're stronger. So these are 4 times stronger than these lines. And then when you move to the middle, they're going to be exactly equal, because you're now in the middle of the circle. So at the farthest perimeter of the circle, you'll have a difference of 4 to 1, and in the middle, the difference is just 1 to 1. You can sort of understand it. In the middle, it's going to be exactly the same distance from both particles. But anyway, the point is there's no imbalance because the pressure is equal on each side of the line. So as long as you're, let's see how to put this. It's just what a circle does. I'm just saying to you that the point is that it's just the idea that this just compensates for that inverse square property. So I just don't know how to explain that exactly, but what I'm saying is this is pretty much the explanation. I would argue that right here, that this is going to be a 4 to 1 ratio. So there'll be 4 times more mass on this side than there is on this side when you're on the furthest point. And when you get at the middle, it's 1 to 1. And the relationship is just changes, like 1 to 1.2, and then it's 1 to, well, I did 4 to 1. I should do it the same way to be consistent. So it would be 1.2 to 1, and it would be, 3 to 1 would be here. So depending on how deep you are in this, in this circle, would change this relationship. But the maximum will be that 4 to 1 relationship. And you can sort of see it visually. This looks like there's 4 of these in this. So anyway, but I just mean that this is a really important part of understanding gravity, because you have to understand that we're at the maximum point in what you can experience as gravity on the surface of a body. On its on where the density of its mass gets less dense. So we're on the place where the mass, the matter, is its densest. The right way to say it. Might be a little tricky, so I want to be careful. But obviously the atmosphere is much thinner than the crust. And it's at that point where there's going to be much more mass under us than above us. And that's the maximum point. And I'm just saying that as we start to go into the earth, as you start to go into the earth, now there's less mass between you and this other surface. So now there's less blocking of gravity coming from this side, and so the gravity coming from this side is now stronger. What's the point of what I said that exactly backwards. Because you're now deeper, this stuff more of these will get through, because this amount of blocking isn't happening anymore. So you take away this much blocking, which means that now more of this gravity will get through. So now there's more pressure pushing you in the other direction. And obviously at the center, there's equal pressure, or equal blocking from all directions. So there's no gravity. So the center of the earth, there's no gravity. So that's an important thing to think about, like what's going on there then. Because you'd think that that's going to be a place where now that you're under no pressure. But the matter out here is feeling the gravity. It's trying to accelerate in, and it can't get there. So it's obviously pushing, materially. So the gravity has given the matter acceleration, and the acceleration is moving the matter towards the center. And so the stuff is getting pushed, but it's getting pushed by indirect gravity. It's getting pushed by gravity expressed as acceleration, where the gravity that's affecting you isn't material pushing you down. Well, in air pressure it is. We feel the air pressure is what holds you together. gravity isn't holding you together. Air pressure is holding you together. If I took away the atmosphere, your body would explode. Okay, because it's the air pressure that's forcing your matter into a body form, and it wouldn't be able to be held together. If I put you in space, you have too much pressure inside because you've learned to balance the pressure on the outside, the air pressure, and so your body would expand and just, bubble, boil. I mean, you wouldn't explode, but you'd make a mess. Space would make a mess of you. What else? How else do I want to say that? So I mean, we have these perceptual. There's a lot of things that get perceived wrong. Just because we're on complex layers of this mechanism, and so the air is doing something that we're blaming on gravity. What do I want to say? Anything else about that? I'm just trying to say there's a difference between you being pushed by something physical, like your hand pushes something. It's hard to think of that as gravity, right? That's just matter pushing matter. But it was gravity that gave things the acceleration. So, in a sense, it is gravity, but we don't associate acceleration of matter, because it can be in any direction, with gravity. But it is. But the point is that acceleration of matter seems like a different force than gravity. And it sort of is. Gravity is affecting your nuclear bits. Forces are also affecting your nuclear bits, but again, they're doing it for a very specific direction. Like when a bullet hits you. Okay, it's gravity, but it's focused gravity. It's essentially a laser beam of gravity. It's focused gravity. But it has to be understood that it's being expressed not by the little bits moving, but by the bigger bits moving. But they got moved. The little bits do all the moving. Everything is subnuclear. There is no happening that isn't subnuclear. Those are the only bits that are moving. The photons and the gravitons are moving. Everything else is just a pattern of those things. So nothing else really moves because the little inside bits have to do the moving. I've tried to explain this before, but it's just an illusion. Matter's just an arrangement of movement. It's not a thing itself. You are the little bits. You are not anything else. And each little bit has to be individually pushed. They don't get dragged along. They get pushed along. They have to be pushed. They have to be individually carried. When I moved my hand, every subnuclear bit had to be individually, essentially, carried to that location by this graviton pressure. Had to be, these arrows had to be focused, channeled into beams of energy that pushes those little nuclear bits. You're probably not going to get that, but I think that covers it. Well, anyway, I'm getting tired. So I want to do more physics videos. I've just been so damn busy. There's so much else I'm working on, and it really does piss me off because I got to get this done. I want to get this done. I want to get this over with. Yeah, and it's a year now. I thought I'd have better results than this, but whatever. And I'd do more writing, but I'm just saying that it just explains it all. It's all explained. by kinetic gravity. It's the answer. It's the quanta. It's quanta. Quantum mechanics is kinetic gravity. That's all it is. There is no other quanta anything. That's the story of the game. It's just directional arrows, and they're exchanged by this kinetic phenomenon, like the kinetic balls that bounce off of each other. One ball goes in, one ball goes out. The ball that came in isn't the ball that went out, but it looks like it could have been. It's exactly the same as if it was. It's a, it just doesn't matter. You can have a pendulum swing that's just one ball that swings, or you can have a pendulum swing that's just one ball transfers the energy into the other ball, and the other ball moves. Same thing. And the universe is running on that principle. So anyway, I think this is enough. But this hollow gravity thing is really important because that relates to electricity. Because electricity is doing that. And and then magnetism is an expression of electricity. So it just explains all of that too. Is a fundamental feature of that phenomenon, of the fact that gravity is diminished as you go inside the object. There's less gravity. Inside the atom, there's less gravity. Outside the atom is the maximum gravity. Inside the atom is the least gravity. But the highest magnetism, which is another story. But anyway, okay, enough of a video. So hopefully I can get on to law 2, but yeah, I'm gonna have to watch law 1 again and take notes and figure out what I need to move on to. I know I have to get to magnetism and electricity. But anyway, so till next time.